For phosphorus trichloride, we first need to determine the valence electrons before drawing our Lewis structure. So, if you refer over to our periodic table, we can see that phosphorus is in group 5 and chlorine is in group 7. So, phosphorus will have 5 valence electrons plus our 3, because there are 3 chlorine atoms, 7 valence electrons from chlorine. That will give us 26 valence electrons. Now that we have the number of valence electrons, we can go ahead and start creating our Lewis structure. So looking back at the periodic table, we can see that phosphorus is further away from fluorine than chlorine is, therefore making it our least electronegative atom, making it our central atom. Now we can draw our chlorine atoms on our phosphorus atom. Now, looking at this, we know that phosphorus does not have a complete octet, but I'm going to go ahead and first fill in our valence electrons for chlorine. That was 18 around plus 6, that gives us 24 valence electrons. Now we need to add 2 more valence electrons on our central atom, phosphorus. Because we have a lone pair of electrons on our central atom, we know that the electron pair geometry and the shape are going to be different. So the electron pair geometry is going to be tetrahedral. So now that we have all of that information, we can go ahead and get our 3D shape. Still having phosphorus in the middle, and I'm just going to first start by drawing our lone pair so I don't forget about those. Then I'm going to draw our first chlorine atom, giving it a full octet. Then I will be adding, using dashes, our chlorine atom. And then lastly, I will add our final chlorine atom using a dash. This 3D sketch gives our shape a trigonal pyramidal Because it is trigonal pyramidal, we know that our degrees are 109.5 degrees. So after we get all of this information, we are then able to determine the types of forces between these each atoms. So first, going back to our Lewis structure, just because I think that this is the easiest way to see which intermolecular forces it has. So we have, yes, this chlorine atom does have a full octet. It's just out of the camera frame. So first, we can start with hydrogen bonding. There is no H bonding because there is no hydrogen bonded to oxygen, fluorine, or nitrogen. Nitrogen. So now that we get that one out of the way, we can then go, and we know that all elements have LDF, which stands for London dispersion forces. We know this because this is present in everything. Now the last and final one that we have is dipole-dipole. And this is present in all polar molecules. Phosphorus trichloride is a dipolar molecule, therefore making it have dipole-dipole interactions. Thanks for listening.